Okay, good morning class. So today we're looking at congruency and similarity of triangles. Okay. In this lesson in particular, we're going to look at similarity only. Okay. So similarity. Similarity, the mathematical notation for similarity is these three lines going down. Okay, three straight lines. So we are told that similar triangles fit inside one another, as you can see here. That means to say that the two triangles have, number one, three pairs of equal angles. And if the three angles are equal, we call it equiangular. Okay? So if all the angles are equal, it's called equiangular. Number two, the corresponding sides are in proportion. So if you look at this here, you got from 4 to 8. What did I do? Multiplied by 2. Not so. What's 2 times 2? 4. What's 3 times 2? 6. That is what is meant by when they say the sides are in proportion. So whatever factor you multiply it through by, it is applied throughout the triangle. Okay? So let's read it again. Similar triangles fits inside one another. That means that two triangles have three pairs of equal angles, which is equiangular, and the corresponding sides are in proportion. I forgot to say corresponding. Because if I multiply 2 by 4 by 2, I get 8, but I can't put 8 here. Can you see that, people? It must be the corresponding sides. Okay, the side linked to the side in question. Namely, 8 over 4 is the same as 6 over 3, is the same as 4 over 2, which means to say all gives you an answer. Okay. Now the next question says, to prove two triangles are similar. How do we prove two triangles are similar? You only prove that two pairs of angles are equal with reason. The third pair of angles will automatically be equal because of three angles in a triangle. Like say for argument's sake, we're going to prove these two triangles are similar. Okay? And we know that that angle is equal to that angle. And we know that this angle is equal to that angle. And we weren't given this angle here. So from this triangle, we got 30, 70, and they must add up to 180, so this angle has to be 80. But if you have in another triangle 70 and 30 again, then this angle has to be 80 because of the angles in the triangle will always be the same, which is 180. Does it make sense, people? Okay. So to prove that two triangles are similar, we prove that they are equiangular. The angles are the same. The two angles are the same. Then automatically the third one will be equal. Example of similarity proof. Okay. So the question, this is the example on page the example is on page 145. Right, so here we are told that you all see now, I know this picture is not too clear. You all see. So here we are told prove that triangle ABC, which is ABC, is similar to triangle AED. Okay. So ABC is equal to AED. So, as we do in similarity and in congruency, we name the triangles we're going to work in. Okay? So what do we say? In triangle ABC and triangle AED. Note that I didn't say triangle ABC is similar to triangle AED. Why do you think I didn't say it's similar? Because we must prove that that is the case. Does it make sense? We must prove that it's similar. So what do we say there? Remember in this diagram, just in case you can't see clearly, we are given that DE is parallel to BC. We are given DE to be 9, EA to be 6, AC to be 14, and BC to be 12 centimeters. Okay. Alright. Again, when they ask us to prove that two triangles are similar, what do? We prove that two angles are equal with reason. Not so? The two triangles I want you to calculate, or to prove that they're similar, it's A, B, C, and A, E, D. Those are the two triangles. Okay. So you can tell me the first angle that's the same. With reason. Which angles are the same? Yes, Michael? Angle A1 is equal to A2. Is that what you're saying? Why? You see that, people? Angle A1 is equal to angle A2. Why? Vertically. So, how many angles do I still need to prove is equal? One more. Why was that? Because I need two. The third one automatically will be equal. Not so? So which other angle is equal here? Yes. Angle C is equal to angle D. Why? Why? Because of alternate angles. Can you see that, people? So angle C is equal to angle D. This is his alternate angles with BC being parallel to D. So what can I say in conclusion? Angle E has to be equal to angle B. Why? Angle E is equal to angle B. Why? Again, alternate angles, not so? Or it is the third angle in triangle. There's now a new reason that's going to add now to your list. No? It's the third angle in triangle. Once we have proved that two angles are the same in two different triangles, then the third one has to be the same. So it's known as the third angle in triangle. Okay. At this point, is there any confusion? Huh? No. Let's go through it again. If they ask us to prove that two triangles are similar, what do we have to prove? We prove that two angles are equal, automatically the third one will be equal. And when we do the proof, where do we start? We say in triangle ABC and triangle AED. Okay. You guys got it so far? Nothing hectic, no? Now, we conclude. This was enough to prove similarity. So now I say therefore, triangle ABC is similar to triangle AED. But now all these important people. Let's see here. Maybe start with angle A and this angle A. Is angle A equal to angle A? Yes. Then angle B and angle E. Is angle B equal to angle E? Yes. Angle C and angle D. Is angle C equal to angle D? Yes. People, the order is important. So say for argument's sake you went with BCA. BCA. Who must book here now? Cover BCA. Then what would the order of the other triangle be? So it is B. Then it must be E. Then now it's D. So it's C. So it's going to be D. Not so. What if it was triangle BCA? No, that's the same. What if a triangle BAC is similar to triangle? So BAC. So it must be ED. E. So we B was E. Then I went to A, so it must be A. And then C must be T. Will you guys understand? No? So normally the order that they give us is always the correct order. Not always, I can't say always. Okay, sorry about that. So as I've indicated here, thank you Michael. As I've indicated here, that order is important. Also, the order given is normally the right order. Okay? Order given is normally the right order. So people, we need a reason, of course. Not so. And the reason here, I'm going to take this off. The reason here is angle, angle, angle.
Your attention, please.
How did we prove that those two triangles are similar? We proved that it is similar by saying that A, angle, angle, angle.
So the surgeon can please report to the office for a connection.
Give me a minute quickly and I'll explain something else to you.
Thank you.
Okay people, so what's the reason for similarity? Angle, angle, angle. Okay. So with that, from a similarity question, we always get a distance question. Okay. And this is where it gets exciting. Okay. Then again, all sums are exciting. Yes. Okay. So people, from similarity, we conclude. So if they are equiangular, the sides are in proportion. And this is also the reason why the order is important. Okay? Because AB over AE is equal to BC over ED. Can you see that? Is equal to AC over AD. Can you see that people? What if you add triangle XYZ is similar to triangle ABC? What will this be? Everybody together now? XY over AB is equal to YZ over BC equals XZ over AC. And so on and so on. Okay. So from there, the reason for this is that triangle ABC is similar to triangle AED. That's your reason there. Okay? Because we prove similarity, therefore we can conclude this to be true. Okay? You all agree with that? Now we go and say, okay, the question is to calculate EB, that's a B, and CD. So what is AB? What's the length of AB? AB is unknown, not so. So AB remains AB. AE, what's the length of AE? 6 equals BC. BC is 12 over ED, which is 9. Can you see it? Now we got the known ratio here. Is equal to AC 14 over AD, which is unknown. Okay. So do it again, or you guys understand? Understand. Okay. Now remember, they want you to calculate EB. But what do I need for EB? I need to work out AB first, not so. What do I need for CD? I need to know AD is, not so. So, this is now a known ratio to us here. So I'll couple those two now. Okay, those two together. And I solve AB. So what do I do is I cross multiply, where you find an LCM. So AB times 9 is 9AB. 6 times 12 is 72. 72. 72 divided by 9 gives you an answer of AB to be 8 centimeters. But I haven't answered the question. What was the question to work out? So this is now 8. No? The question was for EB. So therefore, EB is going to be 8 plus 6, which is 14 centimeters. Okay. Is that too much at once? Okay. So I'll go a bit slow on the other side. So to calculate AD, what do we need? So we're going to say therefore 12 over 9 is equal to 14 over 80. So what do I do here? Cross multiply. So 12 times 80, 12 80, 9 times 14. Okay. How do I get 80 on its own? Divided by 12 both sides. It cancels. So 80 is equal to 3 goes into 9 thrice, 3 goes into 12 4 times. 2 goes into 4 twice, 2 goes into 14 7 times. 3 times 7 is 21 over 2, or 10 and a half, or 10.5. Okay, so if you look at AD to be 10.5 now, is it 10.5? So therefore, the whole length of DC is going to be DC is going to be 10.5 plus 14, which is 24.5. Okay. Then what I suggest you do is you watch the video again before you do the homework. It's fairly simple. In tomorrow's lesson, I'm going to do all 3 sums on the board. Please attempt it. It's exercise 1 on page 146. You do all 3. You will enjoy the rest of your day. Good afternoon, class.